It's a navigation problem again. It was very, very foggy. Let's get some of this fog out of here. So Milwaukee, Wisconsin is directly west of Grand Haven, Michigan, on opposite sides of Lake Michigan. On a very foggy night, a law enforcement boat leaves Milwaukee at a direction angle of 345 degrees, the same time that a small smuggling craft leaves Grand Haven at a direction angle of 255. Okay, my guess here, you want to know, well, Mr. J, what year would you say this probably was set? I'd say probably during the 1930s, during Prohibition. Chicago is right down the lake from here as like mob central, and the mob owned all of the smuggling operations. They're in charge of all of that, and they had to get their booze somehow during Prohibition. So that is my guess. Let's get the rest of this fog out of here. You can't see what's going on. So we're gonna law enforcement boat leaves Milwaukee. You got smuggling craft leaves Grand Haven, and they collide. There's a boat fire. You got this pillar of smoke. Let's get rid of the rest of this stuff. We can't even see what's going on with our illustration. Oh, look, there's some arrows there. Okay, so the law enforcement boat is going 23 miles an hour, collides with the smuggling craft. What was the smuggling boat's speed? Okay, well, there's a lot going on. We got rid of the fog and the fire and the smoke, but there's still a lot going on. First of all, um, the other problems that we have done similar to this have given us times and speeds, and we were able to calculate distances. This problem only gives us speed. There's an unspecified amount of time between when the boats leave and when they collide. We don't know the time. We don't know the distance. But that is okay because velocity is also a vector, and we can use velocity to label our vectors. So the next thing that is really important for us to check out here is the particular direction angles. So if we did not have direction angles that were aligned in this particular fashion, here's what we could do. We could say, look, there's an X component and a Y component for the law enforcement vessel. There's going to be an X component and a Y component for the smuggling boat. It doesn't look like the X components are going to have any sort of comparison that we can make, but both boats start directly east and west across the lake from one another, and they both travel the same distance to the south when they collide. So the Y component of the smuggling boat in green has to be the same as the Y component of the law enforcement boat in red. So if we can find the Y component of the law enforcement boat, we've got its speed, we've got its angle, we can say, well, that Y component has to be the same as the Y component of the smuggling craft. We also know the angle of that. We could work backwards to find the speed of the resultant for the green vector. But in this particular case, if we subtract that 345 direction angle and the 255 direction angle, we're going to find a difference of exactly 90 degrees, which means this is a right angle. It's giving us a right triangle, which means we don't have to use the components. We certainly could, but we have another option. We can use the right triangle. So here's our right triangle. In order to do anything with the right triangle, I need to get an inside the triangle angle. If I was a deputy that got left off duty, right, I got left behind back there in Milwaukee, from the perspective of the off-duty deputy, if I look directly across the lake at Grand Haven, that would be a direction angle of 360 degrees. If I look after the boat, follow the wake of the boat of my partners, they left at 345 degrees. This is the direction angle. Between those two angles is the inside the triangle angle. So we can just subtract 360 minus 345 is 15. Okay, so the next question is, what are we going to use to label the two vectors on our triangle? We don't have distances, we don't have time, so the only option is to use velocity. So I've got my 15 degrees. My deputy's now got the badge on. She is an official deputy. She's got her star badge on. I got a 23-mile-an-hour velocity vector for the law enforcement boat. Inside the triangle angle is 15 degrees from the perspective of the off-duty deputy with her star badge. I got an adjacent side and an opposite side, which means I'm probably going to use tangent. When I set up tangent, I noticed that my variable was in the numerator. So I said, you know what, full speed ahead, solve this. So I did my algebra first. So the opposite side is going to be 23 times the tangent of 15 degrees. And that gave me 6.2 miles per hour. If I need to round, I'd round it off to 6 miles per hour if I need a whole number. But 6.2 miles per hour. You can't outrun the law, folks.